Okay, so you've sent us a whole bunch of articles about asteroids and planetary defense, even human extinction.
Hmm.
Sounds like someone's been doing a little doom scrolling.
It is a fascinating corner of the internet.
Yeah, it really is. But hey, that's what we're here for, right? To kind of dive into all this and help make sense of it all. We'll unpack the science, the threats, and even what we can learn from how we've dealt with other global challenges like pandemics. Speaking of which, remember that whole dinosaur extinction thing? Turns out there's been some fascinating new research about the asteroid that caused it.
Yeah, it's true. We're talking about the Chicxulub impactor, the one that slammed into Earth, was it like 66 million years ago?
6 million, yeah.
And that article you shared, asteroid that killed the dinosaurs, came from beyond Jupiter, had some really eye-opening details about its origins.
Yeah, I always just assumed asteroids were just like, big rocks hanging out in the asteroid belt.
Yeah.
But this one came from much farther out, right?
Much farther out.
Yeah.
This wasn't just any space rock. This was a carbonaceous asteroid, a type that originated in the outer solar system beyond Jupiter.
Oh.
Imagine, like, way back when the planets were still forming
Right.
and things were a lot more chaotic and there were gravitational interactions with the giant planets. Jupiter especially flung some of these carbonaceous asteroids inwards toward Earth's neighborhood.
So this asteroid, this bringer of doom, came all the way from the outer solar system. It's kind of mind-boggling when you think about it.
It is.
What's even more mind-boggling is just how powerful that impact was.
It was unbelievable.
Yeah.
So the impact itself released an unimaginable amount of energy. We're talking like the equivalent of millions of nuclear bombs detonating at once. And to give you some perspective, the asteroid itself was estimated to be about 6 miles wide.
6 miles wide. I mean, I've seen Armageddon, but that's just like a whole other level.
Yeah, it's hard to even comprehend the scale of the devastation. We're talking earthquakes, tsunamis, wildfires raging across the globe.
Yeah.
The impact triggered this chain reaction of disasters. And then to top it all off, the debris thrown up into the atmosphere blocked out the sun, causing this global cooling effect that lasted for years.
Right.
And so it's no wonder the dinosaurs didn't stand a chance.
Yeah, that's some seriously scary stuff. And it makes you wonder, I mean, if an asteroid that big hit us today, what hope would we have?
Well, before we go all doomsday on this,
Mm-hmm.
it's important to remember that Chicxulub was what we call an extinction-level event.
Right.
Asteroids that big are thankfully very rare.
Okay, well, that's a slight relief. But what about the smaller ones? I mean, even a pebble from space can probably do some damage if it's going fast enough.
You're absolutely right. Even smaller asteroids can pose a really serious threat.
Mm-hmm.
And the damage they can inflict really depends on, their size and where they hit.
Speaking of which, one of the articles you sent, can scientists save the world from an apocalyptic asteroid strike? They give some pretty vivid examples of what could happen.
Oh, absolutely. That article does a great job of laying out the potential consequences,
Yeah.
using real-world scenarios.
Like how a relatively small asteroid just a couple hundred meters across could wipe out an entire city.
Yeah,
Poof, just gone.
yeah. And if we're talking about asteroids around 500 meters in size, those could devastate an entire country.
No.
Yeah, we call those country crushers. But even something smaller, like around 50 meters, can have significant regional consequences.
Like that one that exploded over Siberia back in 1908, the Tunguska event.
Precisely. That was a relatively small asteroid, maybe 50 to 60 meters in diameter,
Okay.
but it exploded in the atmosphere over Siberia with the force of a large nuclear bomb. It flattened trees over an area of more than 800 square miles.
800 square miles, and that was a smaller one. Suddenly, that whole doom scrolling thing is starting to make a lot more sense.
Yeah.
So knowing all of this, how do we even begin to protect ourselves?
Well, that's where things get a little bit more interesting. And maybe a little less doomsday-ish.
Okay, well, that's good to hear, because I was about to suggest we just fire Bruce Willis at it and hope for the best.
I appreciate the Armageddon reference. But thankfully, we have slightly more sophisticated methods these days.
Okay.
Hollywood aside, there's a whole field dedicated to protecting Earth from these cosmic threats, and it's called planetary defense.
Okay.
And it's more than just a concept. There are real concrete initiatives in place right now to try to, address this threat.
Okay, so tell me more about this planetary defense plan. What exactly are we doing to protect ourselves from these rogue asteroids? So it's like there's an actual plan in place, right? We're not just like sitting ducks out here.
No, not at all.
Yeah.
We've come a long way from the days when asteroids were just like these blurry dots in the sky. For one thing, we have NASA's Planetary Defense Coordination Office, or the PDCO.
PDCO. Yeah, it's got a nice ring to it.
It does.
So they're like the control center. They're like keeping an eye on things.
Yeah, they're constantly tracking these potentially hazardous objects, coordinating research, developing strategies for, if and when we need to, like, deflect or disrupt an asteroid that's headed our way.
Deflecting and disrupting asteroids. Okay, now this is where it starts to sound like a sci-fi movie again.
Right.
But you mentioned that there have been real missions already, right? Like DART.
Exactly. DART was a huge milestone. It stands for the Double Asteroid Redirection Test, and it was a spacecraft that was designed to intentionally crash into a small asteroid called Dimorphos, which orbits a larger asteroid Didymos.
Okay.
And it worked. DART successfully changed Dimorphos's orbital period.
Wait, so we can actually move asteroids now? Just
Yeah.
like nudge them out of the way?
It's a little more complicated than that, but the principle is sound, and we're learning more all the time. The European Space Agency is actually setting a follow-up mission called Hera to study the aftermath of DART's impact in more detail.
That's incredible. Okay, so we're getting better at deflecting, but what about finding these things in the first place? Space is pretty big. How do we even know where to look?
Well, that's a really critical part of planetary defense, is early detection. The sooner we spot a potential threat, the more time we have to react. And we've got some incredible tools for that. There's the NEO Surveyor mission, which is a space telescope that's designed to hunt for asteroids using infrared light.
Okay.
And it's going to be able to find even those very dark, hard-to-see asteroids that might be lurking out there.
So it's like they're sending out a search party for these road asteroids.
Exactly.
But with a telescope instead of a flashlight.
Precisely.
Hmm.
And then here on Earth, we've got the Vera C. Rubin Observatory, which is a ground-based telescope that's going to be scanning the entire sky every few nights.
Wow.
And this thing is going to dramatically increase our ability to detect and track these potentially hazardous objects.
Okay, so we've got eyes on the sky from space and here on the ground. We're getting good at deflecting asteroids, at least in theory. What else? What's the overall strategy here?
Well, the goal is to create this really comprehensive planetary defense system.
Yeah.
Like, we want to be able to find 90% of these potential threats in the coming decade. We're developing and testing different deflection techniques, not just impacting them like DART, but also things like gravity tractors, even using lasers.
Lasers. Did you just say lasers? Okay, now you're just messing with me.
No, I promise you, this is real science. It's still early days. But the idea is that we could potentially use these really powerful lasers to vaporize part of the asteroid's surface.
Oh, wow.
And that would create this jet of gas that would act like a thruster, slowly pushing it away from Earth.
Okay, maybe I spoke too soon about the whole sci-fi movie thing, lasers, and now we're nudging asteroids. This is incredible.
It's pretty amazing.
So with all this in place, how worried should we be about like an asteroid catching us off guard?
That's a very fair question.
Yeah.
So experts use something called the Torino scale to assess the risk of any given asteroid. And it takes into account its size, its projected trajectory, and the probability of an impact.
So is this like our DEFCON level for asteroids? Like, are we at DEFCON 5 right now?
We're not quite at DEFCON 5. The good news is that none of the asteroids that we know about pose what we would call an imminent threat. We've tracked the big ones.
Yeah.
They're not on a collision course with Earth anytime soon.
Oh, okay.
But it's the ones we haven't found yet that we need to be prepared for. And that's why all these projects like NEO Surveyor and the Rubin Observatory are so crucial.
Right.
The more we find, the better prepared we'll be.
So it's all about being vigilant, staying ahead of the game, which, come to think of it, kind of reminds me of how we've had to deal with another global threat recently, pandemics.
It is an interesting parallel. And you know, one of the articles you sent, why an asteroid strike is like a pandemic, actually makes that very connection.
Pandemics, asteroids. It's like, what's next, right? But really, though, what are the similarities?
Well, for one thing, they both involve a huge number of potential threats. But only a small fraction of those are actually going to be dangerous.
Right.
Like, think about it. There are countless asteroids out there, but only a tiny percentage come close enough to Earth to even be a concern.
Right. And with viruses, I imagine it's those that are capable of, like, jumping from animals to humans.
Exactly.
And then spreading rapidly that we really need to watch out for.
Exactly. That's the thing. Finding those high-risk threats, whether we're talking about asteroids or viruses, it's like trying to find a needle in a haystack.
Right.
And in both cases, early detection and preparation are absolutely essential.
Yeah. It's like with COVID-19, early testing and contact tracing could have made a world of difference.
Absolutely.
Yeah.
The sooner we're aware of a threat, the more time we have to develop and implement effective countermeasures. So in the case of a pandemic, it might be a vaccine for an asteroid. It could be a deflection mission.
Right. So preparedness is key.
Preparedness is key.
Which brings us to kind of another, even bigger question raised by one of the articles that you sent me. Will humans ever go extinct? Is that why you were reading all this? Are we talking like dinosaurs 2.0 here?
Well, it's a question that comes up a lot when you deal with asteroids, let me tell you.
Right.
But, the article actually makes a really good point. Extinction-level threats go way beyond just asteroids.
Like, what else is there? Give it to me straight.
Well, the article lists several. We're talking nuclear war, climate change, even the rise of artificial intelligence. It's a bit of a doom and gloom list, I'll admit.
Okay, well, who's the one doom scrolling now?
That's true, that's true. But here's a glimmer of hope. The article also suggests that a single event wiping out humanity is statistically unlikely.
Okay, so it's not going to be like one giant asteroid or one rogue AI that takes us all down.
Probably not. The bigger danger, according to the experts, is what they call a perfect storm of interconnected crises. So imagine a scenario where we're dealing with the escalating effects of climate change, resource depletion, social unrest, and then on top of all that, we get hit by a pandemic or a major asteroid impact.
Oh, great. So it's not just enough to have one thing go wrong. It's like a cosmic multi-car pileup out there.
It's a sobering thought, for sure, but it really highlights something really crucial. Focusing on these individual threats in isolation might be missing the bigger picture here.
So what are we supposed to do with that information?
Well, I think the point is that addressing the underlying issues that make us vulnerable to multiple threats, that might be a more effective approach. So things like climate change, social inequality, unsustainable practices, these are all challenges we can tackle right now.
So instead of building an asteroid-proof bunker, we should be focusing on building a more resilient and equitable society.
Exactly. And that's a message that applies to all of us.
Okay.
While these big picture existential risks are important to consider, don't let them paralyze you. Focus on the things you can control. The choices you make in your own life to contribute to a more sustainable and just world.
Well, that's actually a really empowering way to look at it. So to kind of wrap this all up, should we be digging underground bunkers and stocking up on canned goods?
You can if it makes you feel better, but I wouldn't necessarily recommend it. Here's the bottom line. We've learned a lot about asteroids, and planetary defense is no longer a fringe science. We have brilliant minds working on this, organizations like NASA's Planetary Defense Coordination Office that are actively tracking these threats, and we're developing some pretty incredible technologies to protect our planet.
Yeah, and with those new telescopes we talked about, like NEO Surveyor and the Rubin Observatory coming online soon, we're going to be even better equipped to find those potential threats before they find us. It's kind of reassuring to know that someone's looking up, even if it's to prevent the end of the world as we know it. But hey, there's always more to learn, right? We've been focused this whole time on asteroids that could directly impact Earth. But what about the ones that could threaten our technology in space? Like our satellites, for example, or asteroids that could disrupt vital communication networks.
That's a whole other can of worms.
It's a whole other deep dive for another time.
Exactly.
Well, thanks for joining me on this cosmic adventure. And for all of you listening, keep those questions coming, keep learning, and remember, we're all in this together, even when it comes to asteroids.